Thanks for introducing. Hi, folks. Yes, as already mentioned, I'm Cyrill. I'm working for the Bank Julius Bär as one of the lead platform engineers, mainly responsible for the automation stack of the cloud and also a bit the on-premise world. A bit about what I will talk. First, a bit on where we're coming from, like our traditional way, our visions and goals, where we want to get. Then a brief recap of the most important concepts, or like the concepts which made us choose our solution, to how we started, how we scaled and grew, and our current challenges, and then hopefully some Q&A. Where we're coming from, the traditional way within the bank, we have like kind of a traditional orchestration engine. It's workflow based. It's a proprietary solutions. It's not like really customizable. You run everything as JavaScript, and it's like has its pros and cons. We operate there over 100 workflows, which operate the bank's infrastructure. So it goes from ordering a virtual machine to provisioning Active Directory groups and these kind of things. They're all wired together. It's pretty complicated. It's operated by a central team, which is kind of a bottleneck problem. So usually if they want to, like, if you say you want to say, like, okay, I have a database, I want to automate something, you need to wait because there's like a huge queue on changes and automation which needs to be done. There's also like a huge approval framework. The bank works very traditional. So if you order a VM, it's not like you get it. There's a couple of approvals from architecture, from line management, from product ownership, and so on. They even can change the order. It's kind of complicated, and it's not really state of the art anymore. To where we want to go, a bit our vision. It's like the vision statement at the top. I will read it out. It's basically that we want to empower our customers with a seamless code-driven platform that unifies infrastructure provisioning across all environments, public clouds and on-premise. So we want to be agnostic through a modern and collaborative automation experience. It's like the main statement we set to ourselves on what we would like to achieve. That's where we're heading to. That means, in other words, we decided we want to go for a GitOps-first approach. So every time you order infrastructure, it should be GitOps-first. If possible, we want to do statefully managed resources. So compared to the previous approach where you just fire and forget and hopefully get what you wanted, we want to you declare and you really get what you declared. And if you change the declaration, we change the, like in the implementation in the backend, the resource to the expected state. There's a few other things. We also said we want to co-locate the application code with the infrastructure. So today the bank has like the development outside or kind of sideways to the infrastructure teams, which we want to bring together to enable real DevOps principles. With that, we're coming to a slide overview of the concepts and patterns which made us going the way we're heading to. The slides will contain quite some text. The text is more meant as a handout afterwards. There will be a QR code which you can scan to get the slides. And I will just talk you through these. They're also more meant as a refresher. The first one, the reconciliation, that's one of the concepts we like a lot on managing infrastructure or like managing objects. It's basically you declare a state, there's kind of a logic which figures out, checks if we have that state or not, compares the difference, takes action, and does that continuously again and again and again, kind of moving your infrastructure in the state you want. That's basically how Kubernetes works under the hood. This concept a few years got extended by the operator pattern, where you basically can extend the Kubernetes API with your own logic, primarily within your cluster and within that workload. So we saw today like a presentation about the Postgres operator, where that basically the folks there were doing that for their operator and what they wanted to achieve with. We also want to extend a bit more, like we also want to manage resources not within the cluster. We want to manage external systems. We want to manage resources across domains, cloud providers, and also internal systems. And that's where like Kubernetes and Crossplane come together, or where we actually fell in love with these concepts. From there, for us, the two main concepts were the providers. We see it as like a one-to-one mapping. You have like some kind of a backend API, could be your configuration management database or anything else, which exposes different endpoints, and you basically map these endpoints to so-called managed resources in the provider. It's basically all we do there. What comes after, we also had it today morning in a talk from Upbound, where they explained Crossplane for platform engineering. It's basically the composition, because if you just now have a one-to-one mapping of the resource, each of them is basically reconciled and put in expected state, but you don't want to have your developers or IT ops managing all of these by hand. That's not really a lot of fun and might also be complicated. That's where compositions come in. We here have a way to combine these resources in a global state, or in a more abstract resource which is useful for our customer. That could be a database in its form of a database. It can mean we register it somewhere in the configuration management database, we create credentials for it, and we provision the database service. So how we started, that's how our initial architecture looked like. From top down, the idea was that we have like the development teams. They either go to our dev portal or to GitLab directly for the GitOps approach. The only thing the dev portal would do is basically talk to the GitLab and provision there the YAML manifests, just that for the developers which are new to the game, that they don't need to learn all the specifications, or that you kind of get the guidance without knowing all by heart. From there, it's being pulled. We see it here from our Flux, which is our GitOps integration, onto a single Kubernetes cluster. Being processed there by Crossplane, we've installed several providers, some for our public cloud provider, others for GitLab. We have one of a secret vault instance where we can store secrets and credentials. We set up the validation in a way that we here on the right side have like validation services. So we talk to our configuration management database to verify certain inputs. We talk at the bottom to the backend system to provision the things. It's like the initial idea we had. That's how we started. Of course, with that, we came with a lot of problems. Scalability was an issue. In terms of, it sounds easy, you just install a provider, but what happens if you onboard two teams? Just say you have one which is responsible for managing your Kubernetes clusters at the cloud provider, and one which does like the databases in the cloud provider. What do you do with them if A wants to have provider version AB and the other one CD? That doesn't work. You can only install one. So either team you have to tell, okay, you need to do something different, or just accept that you now have another version, which might not work for them. This was one of the problems. Then we had compatibility concerns in ways of like if we do compositions or composition of compositions, how we layer them together, how we define interfaces, because you can just do whatever you like on there. And we still had our bottleneck. We still had we're a team of two doing the integration of the new automation stack, and basically I was the bottleneck. Everyone was approaching me, okay, Cyrill, can I onboard to your automation? I was like, yeah, in 3 months I have time. But that's not how it should be. It should be, you can onboard, yeah, sure, there's the guide, just do it. That comes a bit with how we now scale and grow. That's from there how we evolved. The first concept we introduced here is the task distribution. The primary idea is we scale control planes. So our idea was, okay, we have a diverse amount of teams having a lot of domain-specific knowledge. I do not have, because my one is the orchestration. So why not give these teams their own control planes? Now that brings a new problem. If everyone has its own control plane, you don't want to order, if you go back to the database example, you don't want to order a database at the database team and then you go to the configuration management team to order a configuration management for your database and so on. Like, you want to have still that all out of a box. It comes in where we have the bottom layer. We had new names for these kind of things, so we introduced like the commander. It reflects like our central instance of the control plane. That means it's the main one. It allows us to control what APIs we expose to users. So it's like the moment you onboard there, you need to talk to me. But onboarding means we just combine different blueprints. So if you come and say, okay, Cyrill, I have a new database service, then I say, okay, look, we need to do a new composition. It's looking like that for the database. That's the values you want. Some we can inherit because we know contextual information. So we know, like, if you deploy a database for application A, we know that you deploy it for application A. We don't need to ask the user for that. We know that. So we basically inherit these contextual informations, and we also then combine, like, do you need these duplicate fields? Maybe you can do it simpler, because our goal in the end, like today we provision a Kubernetes cluster with 3 user inputs. You need to give it a name and a size, basically, and then there's like 1 additional metadata, which is for the bank itself. And that's all we need. It also allows us to basically enrich, so at a later point, if a new system comes, let's say we need to register in a different Entra provider, like in Azure, you would register in Entra ID for now if you want to migrate. You could just add a new unit to it, like a new automation provider. That's the upper layer. We'll cover that soon. Basically, just add everywhere where you need this object, we can add it to all the existing composition, and what will happen is we'll provision for all the existing resources. We will provision later on when a new thing gets added, them the same. In the previous one, once you had a workflow engine, we always need to do migration. So today, if we provision with the old automation a VM, and we want to change that, like right now we're doing a change on the permissions, it takes ages because there is someone figuring out how to do it for each and every VM individually. The new approach is like adding it to the composition, all will get it. The upper layer is the unit, that's the entity we give to each team. We'll follow up on that on one of the next slides. Internally, we called our product at some point Fleet Commander. It somehow evolved in a product as there was the need to market it inside the company, because you could just come and say, we have Crossplane, and then they Google and kind of find the information, but not on how we do it. That's where Fleet Commander came across. It contains multiple components. We have the commander, the units, which we already looked a bit at. There's something called core, and we have the composition function framework. We'll also cover that in one of the next slides. First, let's have a look at core. From the idea, all the control planes, even commander, they have various things which are similar. All of them are operating an internal certificate authority, because we want to authenticate with our Vault instance and different kind of things. They all have a backup utility built in, how we back up Crossplane objects. And they all, of course, contain Crossplane and a couple of other smaller components. So we share that base. It's all tracked in a monorepo. And we also provide with the core some helper utilities, like how to install a provider where like all the offline settings for air-gapped environments are already pre-configured. We also provide a way on how we install a unit, because if you now come to us and you want to get the unit, you don't want to ask me. It's part of the documentation, and unit installation means you fill a values file of a Helm chart, and that's basically it. We'll cover that in the next slide. That's today more or less how the unit provisioning looks like. If you look from the very left, we have like new CRD or XRD in Crossplane terms, which says I'm a unit. or actually I want to have a new unit. You put that into GitLab. It's like 5 lines of configuration telling where your content is coming from. Content means providers and the compositions. What we then do, we sync that into our Crossplane, the Commander instance. Commander in itself, or Fleet Commander in itself, the minimum we need is our unit which provisions Kubernetes clusters and ourselves. Because our whole solution today is based on real Kubernetes clusters. It means we provision in the composition, we provision a kube config, where we get that, we provision a new Kubernetes cluster. We do the linking for the provider Kubernetes on how, that's like the way how we talk to these, like how the syncing between the commander and units work. On the Kubernetes unit, there's various things happening. I actually don't know. It's part of their domain-specific knowledge on figuring out what they need to do. All I know is we call that interface, and that interface is the abstraction to everything. So we just defined once, look, that's how a Kubernetes cluster looks like internally within the platform. What they do, we don't care. Of course, I know a bit because we built the solution together. They talk, of course, to to our public cloud provider, and they have some kind of bootstrapping magic where they set up all the Flux installation to sync content and install the unit's content on top of it. Before, I also mentioned we have the composition function framework. You haven't heard that term. We'll explain why. We decided we go for compositions with Go. The reasons why it's strictly typed, because we started initially with the YAML, like the Go YAML function, where you just like declare the manifests, and the Kubernetes one grew up over 2,000 lines, and no one had any clue what YAML we actually provision. And if you changed something, it was like a surprise if it works or not, or if the formatting is correct. Of course, there's now also like a lot of stuff changed in the community, but at the time when we decided, for us, Go was the most reasonable way to go. We can actually do unit testing of it. So we have all in one repo, like all the compositions, and we run extensive units testing against. We even can test because it's Go, we generate the CRD or the XRD also with Kube Builder. That means in the code base they are strictly linked. So if you change the Kubernetes composition and add a new mandatory field, we will notice it on our commander on the unit template. The unit test will fail. You will not get it in production with that. So it protects us from a lot of failures, and it also brings the power of a programming language, so you can really do a lot of funny things. Why I say that, we soon had to learn that not everything is as nice, and external names are like predictable. We automate against GitLab, and there the external name is a random ID. And predicting random IDs, if you provision hierarchical structures, it's not that fun. Because you always need to wait till the object is fully provisioned, till you can in the composition provision the next object, which is like, it's just messy. And there the programming language comes in handy. Debugging is also nice. You can really step through the code and see what the composition is doing where, especially if you have large code base. And you only need to learn a single language. Remember, we still have teams which are not on public cloud or like running proprietary systems. They need to implement providers themselves, and then they anyway need to learn Go. Now, what we did for the Go to make it a bit easier, because we found the way on how Crossplane is doing the functions in Go. It's nice if you write like a 2-liner, small composition, that's nice, but as soon as you have, like in the ACAS case, we have over 100 objects we provision. At some point it gets really messy if you just have one function. As the template says, you have everything in there. At some point you also lose track what happens where. So what we did, at some point we defined an XRD, or like it's like always a one-to-one, a function belongs to one XRD. We don't do anything cross because it gets unpredictable. We only do strictly typed, so there is no map interface string or anything like that. It's all strictly typed always. We provide utility functions for contextual information. So all within the bank use the same utility function, like how to get the application name or these kind of metadata we know about resources. And we kind of try to build wrappers or ways on how you really can just declare, okay, I want to have these objects if this or that condition is met. Like the computation, we're right now in evolving, like we try to get a new version of the composition function framework. Hopefully at some point we're able to open source, but it also depends a bit on the company's perspective. Hope we can change that. To the current challenges we face, a big one is the data exchange. As soon as you start scaling our concept, you start noticing, okay, if I have a team responsible for networking and they provision on your cloud provider a new virtual network, how do you attach the service into that? Like, how does the Kubernetes team know to which virtual network to attach that specific resource? And that's like one of the core problems we have. Today, we always forward the information up and down and only what we really need. But we already had several times the case that new components came up and they said, yeah, but I also need another property, and you start changing all of the references because you want to do it all the way same. It's like right now an idea we have, so we like hopefully in the next 2 to 3 months are able to build like a provider. The idea is that we talk to a central API where we publish information. So sorry. Like you publish the information, like you declare in the code base, I want to publish these amount of settings. That's all which could be relevant for someone else using part of my composition or relying on it. In network, it could be the subnet and other kind of network settings. And on any other unit, you can just say, okay, I would like to request that object. And as soon as it appears in the central store, you will download it or inherit it on your cluster. And from there on, you see it or have it visible in the composition. That would bring kind of benefits because we're not part of the data exchange anymore. So you don't have to tell me, Cyrill, I need another field from this guy and we need to arrange the up and down forwarding. So it's really like would allow us to move data across units without like us involving. It's one of the concepts and ideas we have on how to solve the data challenge. I'm not sure if you had that as well. Would be happy to speak about. We'll see, maybe in a few months they have hopefully solved it. Another one is release management today, but it's more like a problem we baked ourselves, or at least partially. Today, all our environments are end-to-end integrated. For us, that's great. For the units or the dependent technologies, it's not, because we rely on them. And we basically took their testing environment and if they're testing, it's not that nice because either we're impacted or we're not allowing them to test. Our idea is like we would like to mock that. So we'd like from the central piece, from the commander, we would like to introduce mocking solutions. The idea there we have is we spin up like fake Kubernetes cluster where we just simulate a crossplane API. That's like the idea we have right now, which would allow us to develop the commander instance, which is the shared and by far most complicated, in individual iterations without relying on our counterpart. So it really would go in the direction. We and the units, we define the interface on what an object looked like. And from then on, they're independent. They tell us when they're ready to release, and we're ready as well. Last but not least, a bit summarization of challenges. One is onboarding. We have here the monorepo. It brings some complexity because you need to onboard. It also brings a lot of benefit, but it makes onboarding hard. And if you now imagine, like, I'm coming from infrastructure and developer side, so I kind of understand the tools, but we have a lot of traditional infrastructure teams within the bank. And for them, onboarding to a code base is kind of hard because they already need to onboard to how you declare infrastructure and all the other concepts. So we're looking for ways on how we can ease things up there. This kind of reflects also in the adoption. Right now, we're primarily adopting the concepts on cloud resources and related systems there, and not really on the on-prem world. And we really like over time also adopt it to the on-prem world where feasible. There it's also part of the learning curve. I mean, find an infrastructure guy and tell him you now need to learn Go. I mean, they right now or like in the past learned Ansible, and we kind of need to find a way on how we make things for them really easy, that they onboard, like onboarding needs to be a pleasure. That's where we try to head to. That's where also the composition framework hopefully comes a bit in and helps. But it's one of the core problems we right now have. And last but not least, it's costs. Right now, we pay around an average price of $300 per month for a unit. If you now start scaling that, you can do the math yourself. Depending on the size of your organization and the teams, it's getting pretty expensive. Right now, it's not the main concern we have, but over time, we need to do something there. We're also exploring on what we can do, but we definitely need solutions for these kinds of problems. With that, I'm towards the end of my presentation. Here the QR code if you want to get the slides, and I'm open for questions.
No question, even from the audience. Okay, second.
I can speak loud.
No, please. We want to have it on recording.
How long was your journey, like building the whole thing from scratch?
It's nearly a year. So I started beginning of June, and we started with the implementation somewhere in July. So like what you see here, that's all what we experienced within basically a year and how we evolved over time.
That's really impressive. Did you have any other IDBs, IAC solutions like Terraform or something before, or did you just start also from scratch?
We spent around 3 years on trying to onboard to our cloud provider, but the main reason for that was like all the legal and these kind of procedures, which took quite long. But there wasn't really a lot of existing stuff, so we started more or less on greenfield a year ago. At least with all concerning the orchestration, we started on greenfield.
Very impressive. Thank you.
Welcome.